The first thing I think about when I open my eyes in the morning is coffee. Coffee is an integral part of my morning routine, and I never make any important decisions or respond to emails before finishing my first cup. I am always amazed by how just a few sips of coffee gives my brain clarity that I need to tackle the day. And I know that most college students and working adults feel the same. But the question I want to raise is why? What can chemistry offer by way of an explanation? Well, wake yourself up and let's find out. This is ASU. I have a very distinct memory in college in one of my biochemistry classes where I became quite curious about why coffee is so effective in driving sleep away. Of course, I knew that coffee contains caffeine, which we all know to be a stimulant, but I wondered why caffeine had this effect in our bodies. There are many different ways in which caffeine affects our brain, but it turns out the molecular structure of caffeine plays a large role in how it functions within our bodies. If you look at the structural drawing of caffeine, you'll notice that it is a combination of two rings, one that is 6-membered and the other that is 5-membered. It is worth noting that these rings also contain nitrogen atoms that are noted with the letter N in addition to carbon atoms. The overall structure of caffeine shares similar characteristics to a different molecule found in your body called adenosine. Adenosine molecules serve an important function in our brain because an increased level of adenosine tells our brain that we need to sleep and get some rest. When adenosine binds and activates its receptors that are found in our nerve cells, this activity increases drowsiness and makes us tired. Adenosine, like caffeine, has a portion within its structure that contains a 6-membered ring and a 5-membered ring joined together. These rings also contain nitrogen atoms, just like caffeine. These similarities in molecular structure make it difficult for adenosine receptors to distinguish caffeine and adenosine molecules from one another. And caffeine will bind to the adenosine receptors. However, unlike adenosine, caffeine does not produce a cellular response that induces drowsiness when bound to the receptor, which works to our benefit when we need a quick pick-me-up in the mornings and during long, drawn-out afternoons full of meetings. There are, of course, related side effects of drinking too much coffee or other caffeinated beverages. When the adenosine receptors are blocked by caffeine molecules, your body will trigger adrenaline as a response to this disruption, causing your heart to pound and blood pressure to rise as if you're getting chased by a bear or preparing for a big match. This is why, when the effect of coffee wears off, you may feel more fatigued than ever because your body was in a full alert mode for some time. Coffee will always remain my beverage of choice in the morning. It wakes me up, yes, but I also find it fascinating that the molecular structure of caffeine is a fundamental reason that allows it to impact my brain the way it does. The simple details matter in science. The relationships can always be explained if you're prepared to follow the logic. And knowing how it works might just allow you to enjoy your morning coffee that little bit more. This was ASU. Thanks for watching.